So I'm Kaylee and I'm going to discuss the concepts of Vue. Has anyone here used Vue before? Has anyone used React, Angular? Okay, well I'm not going to go into a debate between the whole three because I just can't really be bothered. I like Vue, so I'm going to talk about it. So I originally started using Vue because it fits in so well with Laravel, which is what I do the majority of my coding in. And then from the interest in this, I've just decided to delve deeper into it and what's actually going on under the hood, which I'm going to go through today. Obviously, there's a lot more than what I'm going to cover in this talk, but essentially, with these core concepts, you can easily create a powerful application. So Vue was originally created in 2013, and its first release was in 2014. And in that time, it's gone up 2 major versions, and I think the latest stable one is 2.517, so it's come quite a long way. It's inspired by the model Vue model pattern, which is a progressive framework for building user interfaces, and the core Vue library itself just focuses on the Vue layer, so it's easy to pick up and integrate with other libraries and existing projects. But it is also capable of powering sophisticated single-page applications when it's combined with other tools and libraries. So Vue uses declarative rendering, which is the process of writing code that focuses on the outcome rather than the implementation. So you're essentially telling it what to render rather than how. So I'm going to kick things off with the good old Hello World example. So every Vue app starts with a Vue instance, which is how you call new Vue. Inside that you can have an element which you're telling your code to target. In this example I've used app. And then you have a data object. So they're all keyed as well, so I've used text here. And then you render, I don't know what's going on with my formatting. You then render your data using the mustache syntax. Although this is a very simple example, Vue's actually done a lot of work under the hood. So the data object and the DOM are now linked, making everything reactive, but I shall cover reactivity later on. So if we have a list of items that we want, that we know we're going to reuse multiple times, it makes sense to put them into an array, loop over each of them, and then build up the element and add it to the DOM. And this example works fine, but it's very messy for something so simple. Whereas if we implement this on Vue, like on the other side, it's much simpler, it's easier to read, and someone with little to no knowledge could probably pick this up and have a bit of an idea what's going on. So within the example, I'm using a v-for and looping over each of the items in my data array. So I've got like home, about, and contact us, which thinking back is a bad example because you wouldn't use the navigation in multiple places, you just have it in one singular place. So v-for is a directive, and there's quite a few of these within Vue, and they're all indicated with the v dash. So this essentially makes you aware that they're special attributes provided by Vue, and that they apply special reactive behavior to the rendered DOM. So here's a few more of them. So these are probably the main ones I use on a daily basis. So you have like conditional rendering, so v-if, v-else if, and v-else. This is quite good, so if you wanted the top one to be a div, but you wanted the second one to be a span, that's easily done as well. And the next one I use a lot is vbind, so this dynamically binds the attribute or passes the data through to your component as a prop. So this keeps the element's prop attributes essentially up to date with the something on the Vue instance. I've then got v-on, so this helps you attach an event listener to an element. So in this case, I've got a button, and then my v-on is the @click, and essentially I'm calling a remove function and passing the index into this. And then vModel enables two-way binding between the form input and the app state. And vShow essentially uses to show and hide elements based on the state, but leaves it within the DOM. So it show and hides the element based on the state of the show item attribute here. So the element using the vShow will always be rendered within the DOM, but vShow only toggles the display of the CSS property on the element. If is considered real conditional rendering because it ensures that the event listeners and the child components inside the conditional block are properly destroyed and recreated during the toggles. But in the same sense, it's also lazy, so if the condition is false on the initial render, it just ignores it basically. And it doesn't render it until that condition becomes true. So in comparison, vShow is much simpler. The element is always rendered regardless of the initial condition, and it's just CSS-based toggling. But generally speaking, vIf has higher toggle costs, while vShow has higher initial rendering costs. So probably prefer to use vShow if you need to toggle something often, and vIf if the condition's unlikely to change that much during the runtime. So websites are essentially built up of a lot of components, and you can break these down. So you can see here I've essentially got an overriding container with 3 elements inside it, and then 2 are broken down even further. So one might be articles, one might be like gallery items. And the best way to use Vue is to break things down into the smallest sections that you can, and then essentially abstracting the whole site into smaller pieces or components, which makes it easier to structure, easier to reuse and manage, and it also makes your code a lot more legible. Also with this tree structure, data can be passed down from the parent to the child elements via props, which I shall also go into, and it can be like passed back up the tree using emit. So components essentially help you extend basic HTML elements and encapsulate reusable code. At a high level, they're essentially just a named element that you attach behavior to. So in this example, I've got a Vue instance with the name of button counter, and components can be either called within the root Vue element or locally, can be registered within the, I'll start that over. Components can be either called inside the root Vue instance, and they can be called as many times as you want. So you can see on this example, I'm calling it 3 times. So as long as you've registered it, like at the bottom where I am importing and then declaring it as a component, there's 2 ways to define a component. So you either use kebab case or Pascal case. If you define something with kebab case, you have to use kebab when you reference it, whereas if you use Pascal, you can either reference it with Pascal or kebab case. So in this corner example, as I've called it 3 times, each component essentially has its own data option. So you can see in the top example, the data option actually now becomes a function. So if this didn't happen, essentially when you click button 1, the counter would update for all 3 buttons. which obviously isn't helpful. So by giving each one their own data function, it helps to split it out so you can enable the functionality that you want. I mentioned that data is passed to the child elements via props. So props are essentially custom attributes that you register on the component. And when view is passed to a prop attribute, it becomes a property on that component instance. So on here I've got an article component and I'm passing through the article title and key. And then within the component on the other side, I've got props and title, and obviously forgot to mention key when I done that. So any value can be passed through as a prop. It doesn't just have to be an array. And within the component, they're essentially referenced the same way that you access a normal data attribute, so using the I can't say it, curly braces. So obviously in this example, I've hard-coded some articles, but usually you'd return this result from like an API call. But you'd essentially do it in the same instance. You just call it within a function and then pass the data back to the data element. So sometimes you might require to pass the data back up to the parent, and this is done with the use of events. So let's say on each article we have a marker's red button. When the user clicks this, we need to remove it from the list. So the parent component needs to know which article to remove from the list. So on the child element, which is the one over there, we're calling emit, passing the function name, and then passing the ID that we want to remove. So, and then on the parent component, we essentially need to have the method and the function that we're calling, is the remove item at the bottom. So I'm essentially getting the ID and then removing it from my article array. So as view is reactive, as soon as the user clicks on the marker's red button, it's removed from the view straight away. So it's like an instant flow. So a cool thing that Vue does is it has computed properties and watches. So in template expressions are very convenient, but they're meant for simple operations. So putting too much logic into your templates makes them very bloated and hard to maintain. So your template kind of becomes, it's no longer simple or declarative. It's quite hard to keep an idea of what's actually happening. So in the example, I'm using a simple reverse message functionality. So rather than having this within the component, obviously if you wanted to have this like 5 times on a page or more, it makes it very bloated. So it makes sense for any logic like that or complex logic that you're using often to put into a computed property. So you can data bind to computed properties in templates just like a normal property. So Vue's aware that the reverse message depends on the original message data. So it will update any bindings that depend on that reverse message when the message itself changes. And the best part is that we've created this dependency relationship declarative. So the computed getter function has no side effects, which makes it easier to test and understand. So essentially where I'm referencing the reverse message, it's just calling this computed functionality which does exactly the same function as I'm doing in the original example. But just easy if you want to reuse it. Obviously this is not really an example you'd want to reuse multiple times. But for things like calculating totals or formatting numbers, it's very useful for that. So a computed property will only reevaluate when its dependencies has changed. So as long as the message hasn't changed, multiple access to the reverse message computed property hasn't changed either. So once that's been updated, it instantly updates the reverse one. Computed properties also cache the outcome, so it's basically cached until your data object is updated, which also helps with your app speeds and so Vue does provide a more generic way to observe and react to data changes on a Vue instance, which is watch properties. So when you have some data that you need to change based on some other data, it is tempting to overuse watch. However, it's often better to use a computed property rather than a watch callback. So in the example, I'm essentially watching the first name, I'm basically building up a full name, but by watching the first name and the last name. So each time the first name's updated, I'm updating the full name. When the last name's updated, I'm updating the full name again. Which obviously is very repetitive. Whereas if we compare it to using a computed property, regardless of whenever the first name and last name is updated, that's just going to return it instantly. So while computed properties are more appropriate in most cases, there are times when a custom watcher is necessary. So this is most useful if you want to perform an asynchronous or an extensive operation in response to the data changing. So the cool thing in Vue is slots, and they essentially allow us to achieve high component customization with little code, and the little code we use is reusable, keeps it clean and keeps your code dry. So it can essentially be viewed as a placeholder for content. So some common usages would be like a button, a modal, cards, drop downs, or like layout components such as like a header, your nav bar, footer. So the slot allows the parent component to pass DOM elements into the child. So essentially I've got multiple buttons, each with a different layout, but regardless they're all having the same functionality. So essentially I'm calling a delete button component, and then within the delete button I essentially have my @click event, so I want to remove whatever it is we're clicking on. This might also be like if you want to add in like some modals to confirm that they actually want to delete the item. All that functionality would go into here. But essentially, where the slot tags are, we will replace with either like delete or the delete and then the icon or icon delete. Essentially, whatever text you want to give it, you just pass through using the slot. Slots can actually contain any code, including HTML or other components. If the no slot element is in the child template, then the parent content will just be disregarded. So if I didn't have the slot templates, the delete text just wouldn't be there. It's also quite helpful when you're using the same button but just 10 times on like the same page and just for different things. Just saves writing a lot of code. There's also times where you'd want more than one slot on a page. So in this example, I've used like a header, a main, and the footer, and I've also got like a main tab. So essentially I'm saying this template slot header, so essentially my H1 tag is just going to go where the slot name header is, and the same with the footer. And there's also the other slot within the main tags at the side. It serves as like a default catch-all for anything that hasn't been named or that doesn't match other named items. So that works well for like a layout side of things. So sometimes you'll want a component with a reusable slot that can be access the data from the child component, sort of like reverse property passing, and this is where scope slots come in. So the first screenshot is a simple to-do list component containing the given within its template. But in other parts of the app, we want the individual items to render differently, and rendering something different to the default text. So I'm giving it a default of the to-do.text, but in some scenarios we might want to check if the item's actually completed and then give it a tick next to it. So essentially we pass the slot any relevant data, and in this case I'm passing it the to-do object. And this essentially creates a local variable for anything inside that template, allowing you to access it as if it's the parent scope. So now when we use the to-do list component, we can optionally define an alternative template for the to-do items, but with access to the data from the child via the scope slot attributes. So essentially checking if it's completed and then adding a tick. If not, just leaving it at the default. So I mentioned that Vue is reactive. So essentially when you change a data value, it triggers an update of the page to reflect that change, making state management simple and intuitive. So it's not just data properties, but also on computed properties, binded properties. It works via getters and setters. So a Vue instance is created, and then each data property, component, and prop, and so on is transversed, and getters and setters are added. This allows Vue to perform dependency tracking and change notifications when properties are accessed or modified. So each component instance has a corresponding watcher, and this records any property interactions during the component's render. So once the dependency setter is triggered, it notifies the watcher, which essentially causes the component to re-render, which just gives it a constant, seamless updating within the screen. There are a few caveats. So if you add or delete a property after Vue has initialized, be it via a method or a lifecycle hook, Vue doesn't actually know about it, so it isn't able to make it reactive. So it doesn't allow dynamically adding new root level reactive properties to an already created instance. However, it is possible to add reactive properties to a nested object using the ViewSet method. So you can also use the vm.set instance method, which is an alias to the global ViewSet. So as Vue doesn't allow the ability to dynamically add root level reactive properties, it's easier just to declare all the reactive properties up front with either like default values or empty objects. So you could set something as empty string, empty array, but it will become reactive when you set data to it. So if you don't declare everything, essentially you'll get some annoying warnings about a render function type isn't able to be accessed, which is annoying. So each view instance goes through a series of initialization steps, which can be broken down into 4 categories. So these are like creation, mounting, updating, and destruction. So creation hooks are the very first to run, and these are actioned before the component has even been added to the DOM. Unlike other hooks, this also runs during server-side rendering. So it should be used if you need to set things up in the component both during client and server rendering. So there's 2 within here which are before create, and this runs at initialization of the component. The data hasn't yet been made reactive and the events haven't been set up. And then we've got created, and this is able to access the reactive data, but the template and the virtual DOM haven't yet been mounted or rendered. The next up is mounting hooks. These are normally the most used hooks, and they allow access to your component immediately before and after its first render. So, however, these ones do not run during server-side rendering. So we have before mount, which runs right before the initial render happens, and the template and render functions have been compiled, but the template element itself doesn't yet exist. And then there's mounted, which is probably the most used lifecycle hook, especially from my experience, which essentially has full access to the reactive component, template, and the render DOM. So this is probably used quite often if you want to do a request to get some initial data for the elements within the page. So third one are updating hooks. And these are called when reactive properties is used by the component or it changes. This allows you to hook into the watch compute render cycle for the component. So before update runs after the data changes on the component and before the DOM is patched and re-rendered. It allows you to get the new state of any received data on the component before it actually renders. And obviously then you've got updated, which runs after the data changes on the component and the DOM has rendered. It's probably the safest hook to access the DOM after a property change. And then we have destruction hooks. So these are used to perform actions when the component's destroyed. So they fire when the component's being torn down and removed from the DOM. So we've got before destroy, which fires right before the tear down. So the component's still fully present and functional. And it's probably the best hook to use to clean up events or reactive subscriptions. And the final hook is destroyed. So by the time you've reached this, there's basically nothing left of your component. And everything that was attached is now destroyed. It's basically used to do any last minute cleanup or to inform the server that the component's been destroyed. So view templates are incredibly powerful, and they allow you to accomplish almost everything you would ever need in an app. However, there's few use cases which often involve dynamic component rendering based on input or slot values, where they're better served by render functions, but this is only about 95% of the time, 95% of the time, templates will just work fine. So an example of when you would use a render function would be when your template basically looks like this, and there's a lot of conditionals, a lot of duplication, it's no longer dry, it's prone to mistakes. So if I was to update something within the top layer, I'd also need to update it within the second section, which obviously, unless you know what's going on, you probably forget about that second section. So I'm essentially saying, based on my text inputs here, if it's an alert, so if I've ticked the checkbox, then I want to use this top section. If it has a link, then I want to attach the link. If it's got a badge set, I want to add the badge. If it doesn't have a link, I want to do something else. If it's not an alert, do something else. And it's just a mess, to be honest. So to get over this, essentially use a render function. So render functions, there's no template above this code. Instead, it's just importing the additional components that I'm using. So I'm importing alert and badge and link. And then I'm exporting my component. So components with a render function do not have a template tag or property. Instead, they define a function called render, which receives the create element argument, and it returns an element created within that function, and everything else just stays the same. So the create element function isn't exactly a real DOM element, it's more of a create node description, as it contains information describing what kind of node should render on the page, including any child node descriptions. So the create element function accepts 3 arguments. So the first one is essentially what kind of element you want to create. So this can be a string, such as a span or a div, or it can be an imported component. So this will then render that view component as another element. So in this example, in the link element, where I've imported a link component at the top, I'm then using it within the create element. And the second parameter is a optional one, and this is for options. So for link, I'm passing in props, and on alert, I'm passing in attributes. So it's essentially where you specify any information that will affect the component that you're creating. And the third and final argument is where you specify the children of that element. So in this example, I'm essentially checking if there's a link, add it to the element. If there's a badge, add it. If there's an alert, add it. And then returning it all within the bottom, within a div. And this essentially builds up my element. So the code's a lot cleaner from a dry perspective. And if I'm going to make any changes, I only need to make it once. It's also a lot easier for someone to come along and pick up without really understanding what's going on. Although the previous example will work, Vue also allows you to use JSX, which is a lot easier to read. In my opinion, not as easy as the template, but it's pretty close. And just by having like a quick look at it, with limited knowledge, you're able to pick it up. So I essentially keep more or less everything the same. The only changes are I have to use this slots and this option, I think. No. Yeah, so one thing you might notice from this example is that isn't exactly any state for the component. It just takes in options and everything else is done based on the slots and options. which brings in functional components. So the last core concept of Vue I'm going to touch on is functional components. Firstly, a functional component is stateless, so it doesn't keep any state by itself. It's also instanceless, so it doesn't have any access to this. So with functional components, you get the organizational dry benefits of a component, but without the overhead of Vue's reactive system, which will help improve your app's performance. So functional component should be used when a piece of your app doesn't require its own reactive data, and it doesn't need to own any methods, but you still want the convenience of a reusable, isolated piece of code that a component provides. Then it's best to consider a functional component. So the only difference between this and the previous example is that I've added a functional true under props, and I've updated the render function to take a parameter of context. So I'm also putting in the context prop options rather than this option, so I don't have access to this anymore. Also putting in the context children rather than this slots. So essentially the children become essentially the slots. And everything the component needs is passed through context. Yeah, it's passed through context. So this is an object containing props, children, which are an array of the vnode child, and slot data. So this is the entire data object passed to the component of the second argument of the create element. There's also reference to the parent component, object containing any parent registered event listeners as functional components that have no instance, and the event listeners, this would be called from the parent on the content listeners property. So although this doesn't look very different or nicer, it will improve the app's performance as you don't have any internal Vue stuff watching the state of the component, it just renders. Ultimately, you could end up, if you want to build your whole app with render functions. Vue templates do come with a lot of helpful features that add logic, such as binding, vmodel, v4, and so on. But the render functions do not have access to any of this. So essentially everything would have to be manually created. So obviously if you wanted like a v-if, you just use a normal if statement. Or if you wanted a v4, you have to implement with any of the JS methods, so like a for, array map, or an array filter. So that's essentially covered all the main core concepts of Vue. Obviously there's still a lot more that can be achieved via additional plugins, and here's just like a view of the main ones. So we've got like Vue Router, which is good for creating like a single page application for the routing. Vuex, Vue CLI, Vue DevTools, which helps you to develop and find out like the state of data while you're developing your app. And that's essentially all I've got. Has anyone got questions? Yes?
When did you start using Vue?
I guess I kind of winged it a bit for like a year ago, but only really got stuck into it over the last 5 months. Yes?
I hit you with the worst question. So React is very, very similar and super supported by many companies and you know, lots of good forums and whatnot.
Yeah.
Why would I choose Vue over that?
Oh, I didn't want to go into this debate.
Yeah. it's gonna happen, right? Like, when there is a really well supported one, like what made you choose?
I think it's more because obviously I work with like Laravel, and the two kind of like go hand in hand, and they basically support each other a lot.
Right.
So I had like exposure to this earlier on,
Okay.
but I mean I was working on
So it
React
wasn't
earlier, so
a conscious decision of, okay, we're going to do this, that and the other for these reasons. It was just, these go together, so you stuck with it, right?
yeah, essentially. And then because I started using it, I then decided to actually know what I'm doing rather than just
Winging it.
winging it.
Less hipster than React as well.
Well, yeah, that's that.
I don't know. I was using React earlier, so
I think they're essentially based on quite similar.
Yeah,
things,
yeah.
aren't they? But it provides maybe some more convenience. So
Sure. I like that you can use, obviously, JSX and stuff like that. It'd be interesting to see how you, cover your dependency injection and testing and stuff like that as well. That'd be quite.
yeah, I didn't really know how far to go on like my first talk, to be fair.
Yeah.
Anyone else?
It's a nice alternative to Angular, actually, I think.
Oh. So, is anyone an Angular fan? No.
So the Manning Angular book and the React book came out on much the same day. I got them both, started reading them both, and then React just went. Angular is where it's at. But I took a look at React and I thought, oh god, yeah, that's disgusting. And I threw it away and went to Angular, and I went back to React. Actually, in hindsight, it makes a lot of sense.
I think I had the same thing when I looked at Angular. I was like, no.
The whole Java, C#, PHP thing again, isn't it?